Right, so I forgot to press my my unmute mic button, and everyone else.
Oh,
Um, we'll try this again. So, all right. Well, I'm going to give the shortened version. So, yada yada yada. So there was a bunch of maintenance issues that popped up recently. Primarily because there was some breaking changes in libclang that then bubbled up to Clang Sharp, that then bubbled up to Build Tools, and because Build Tools has a bunch of manual code for interacting with Clang Sharp rather than using the amazing Clang Sharp p-invoke generator that Tanner here maintains, it meant that adjusting our code to respond to these breaking changes have been very, very difficult. However, it turns out that was a massive motivator for working on 3.0, and as a result, we are today discussing a bunch of proposals that have come from that work. Um, that do adjust the ones that were discussed, I think, 2 meetings ago. We're just going to go through some of the rationale behind those changes and yeah, what we hope the future of Silk.net will look like. So, shall we get into the pros? Does anyone have anything else to add? Is something else going wrong with the stream? Have I forgot to press a button?
it seems to be fine.
Yeah, I think we're good.
Okay, good catch. Thank you very much. Right. So I did. Admittedly, I didn't really give a lot of notice in posting the final proposal links that we're going to be discussing. So if you haven't been scrutinizing each other's work in Team Talk like most of us here have been, then well, this could go interesting. It will be a bit on the spot, but let's discuss. So the first proposal I have on my list is quite an easy one. It's from
short.
Kitiara. Yeah, it's the adjusting the versioning. So, do you want to go through some of that?
Yeah, sure. So, the adjustment is very simple. The existing established versioning scheme for post 3.0 through to pre 4.0 is that we use the major, minor, and patch versions and leave the revision number in a standard 4 component version always being 0. The proposal is that the revision number will be 0 for released builds, but will be something different for preview builds on our experimental feed. In this case, the proposal, we don't have any specific preference for this in the proposal. The two suggestions are to like maybe have a revision of 1 for all experimental builds, or to have a number representing the date so long as it's greater than 0. And the benefit of this is that as things currently stand with Silk.net, and this is something that has been noticed with our current 2.18 when that was still in the experimental builds, is that because we didn't move up to 2.18 until the final release, the experimental builds were considered pre-release builds from the previous version, and thus were considered to be a lower version by NuGet and other tooling, unless automatic updates and stuff wouldn't work. I don't know how well I explained that, but
Yeah, no, I think that was a good
yeah,
explanation. I think fundamentally the issue is that we don't start targeting vNext until vNext is ready to release. So, for example, the version on the experimental feed and the version that we have in the repo is even after 2.17 is released, it is 2.17 up until we're finally ready to snap 2.18 or 2.17.1, and then only then do we change it before we're ready to release. But that does mean that there will be experimental versions tagged with 2.17 that have actually come after the 2.17 snap, and there's possibly some discussions in changing that. I personally think that it would require us to always know what we're going to work on ahead of time, which is quite difficult. For example, we don't know whether we're going to release just a minor patch or an actual full-blown monthly update, for example. So I'm hesitant to define, we just always increment the minor version by 1 after we've released, which would also solve this problem. But also, we don't know what the size of the update is going to be until we actually snap that update. So I think this is a good solution in that it solves the usability problem with the experimental feed, in that NuGet recognizes that the experimental builds are newer than the released ones, And yeah, I have no issues with it. Again, it's a nice and easy.
Yeah, I think this is fine.
Why not just when you're getting ready to lock down for a release, you snap a branch and you reversion main to the next build, to the next version, and then anything that needs to be done in the next release can be backported, which is kind of the standard branching, patching, releasing setup.
So,
The
I mean, this isn't in any proposal, but this is what I want to do for 3.0 and 4.0. Is that once we start wanting to make breaking changes, then we do that in the 4.0 branch and backport it to 3.0. But that's far, 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 hopefully far in the future. I don't want to be doing another massive update like this immediately after releasing 3.0. But for this specifically, I mean I think it comes down to, like, yes, it's standard, but also it's most of the time unless we're making breaking changes, the commits going back into the shipping branch is pretty much 1-to-1. So we'd be adding a lot of maintenance complications for much reason, without much reason.
I personally am in agreement with Tanner here, but as the consensus has up till now been to not increment the version number immediately, as we don't know what the next version will be, which component of the next version number will be incrementing. I think this proposal is just a good compromise for that.
If you you may not know what the next version will definitely be, but you know that it will be at least a minor increment, and you can always increment the minor one, and then decide we're not actually going to ship a next minor version, and then just update the major. Um, so
That
like
would work, yeah.
updating from 3.0 to 3.01 is always safe. And then if you decide that you need a bigger one after because a big enough change goes in, you can change it to 3.10 or 4.00.
I mean, that's not a bad. Yeah, that's not a bad shout, to be fair.
That's a very eloquent way of saying what I had originally intended this proposal to be before failing to communicate it and settling on this compromise instead.
Hmm.
Yeah, so okay, we can adjust that so that we just always like bump the version number anyway after we've shipped a build. And even if it isn't the final vNext, it's at least higher than the one that we're going to ship. I
Yeah.
guess that's fine. I mean, really, eventually it would be nice if it was automated, so we didn't have to worry about it. But I think in principle, that's fine.
Yeah. That'll be fine.
All right, should I rewrite this to account for that?
Yeah.
Yeah, I'll put some comments on the PR.
All right, cool. I'll work on that after the meeting.
Right, cool. Nice and easy one, but also approved with caveats. So let's see how we go for the next one. The other one is also small, at least compared to the other proposals. This is Kitiara again. And this is regarding the managed structure chain stuff that that Thargy brought in a while ago, which is our high-level wrappers over Vulkan singly linked lists. So, yeah, take it away, I guess.
All right. Yeah, this is, as she said, this is some tweaks and changes to the managed structure chain stuff, which, for those who may not know Vulkan, most structure types in Vulkan have two 4-byte fields in the start in a specific layout, where the first one is a 4-byte enum value indicating what type the structure is, and the second is a void pointer to the next element in a chain. Optionally, it may be a null pointer if the end of the chain is reached. And this is used to allow extensibility in Vulkan, where an extension can add a new struct, which just then gets put into the singly linked list if you're using that extension without having to change the signature of core library functions. And in Silk.net 2.x as it stands right now, we have a set of managed generic types for representing chains of various lengths. We have a complete set for up to, I forget the exact how far we go as far as how many generic parameters. And for the most part, those work extremely well. But there are a few minor issues that I've encountered with it using them extensively. Most notably, that most of the one of the properties exposed by this type is a property that is a pointer to a given numbered element in the chain, and these pointers are not typed using the generic type arguments of the managed chained object, despite that generic type being extant and already known to work. They're rather all typed as base in structure, which is one of two structures defined by Vulkan that defines only the type and next fields, which you can use to inspect those fields without assuming what the type is. And this has a couple problems. One, we're assuming that it's an in structure rather than an out structure, although I've yet to find any actual documentation as to which one is used in what situation anyway. And just it not being strongly typed is very inconvenient here. And incident and the part of the issue here is that the base non-generic chain type that all of the generic ones inherit from defines the head pointer for the first element in a non-generic fashion. So I propose there's two different options I propose for how to rectify that. Either have the either have the member on the non-generic type be a different name, as unfortunately we cannot use new to hide the property due to it being abstract, and you cannot implement an abstract class explicitly. Or as an alternative design, I suggest having the base type be renamed and have a single parameter for just the head type, just to facilitate this operation. So that's item number one in this proposal, is to get those pointer properties to be strongly typed using the generics that we already have, which are already constrained to unmanaged and are already used as pointers internally within the type and in most uses of the type. Item number two, these types implement, these concrete generic types implement a chain of interfaces that allow you to work polymorphically over a prefix of the chain, in the case where you're maybe accepting it from user code in a high-level library that uses Silk internally, or whatever the case may be, offering extensibility in your own libraries. But you still need to know that certain items exist in the chain. We have a chain of where iChain has one type parameter for just the head, and then it's got a sub interface that has two type parameters and adds an additional field. Those interfaces do not define the pointer properties as a result of them not being strongly typed in the concrete types, so that they were left out of the interfaces. So item two would be to add those to the interfaces so they are usable when you're considering the polymorphic prefix interfaces, as if the base type issue is fixed and all of the properties for the pointers on the concrete types are made strongly typed, then that promotion is reasonable. And then item three, as we are now targeting newer .NET versions, I propose adding a get pinnable reference to the head of the chain on all of the concrete types so that you can conveniently fix them for the pointer, even though that is technically not necessary, as the memory is all managed manually by the concrete types as a single block that is allocated unmanagedly using, I believe we use Marshall for that. Well, I could be wrong offhand. And handled manually so it is not subject to being moved by the garbage collector or anything else. It would still be generally convenient to have get pinnable reference just to make it clear what you're doing when you get the pointer to the first item to then pass into Vulkan. And then the last item on this proposal is that there is each of the structures that can go in a chain implement an interface iStructure type, which has public structure type, no argument method, which corrects the structure type field of the object to match what it's supposed to be for that type, as we cannot easily keep that in sync with how just C# typing works otherwise. And that name is, and then returns that structure type. And that's kind of a bad name, be real. And also, now C# or Silk.NET 3.0 will be targeting .NET 8 C# 12, which means that we have static abstract interfaces now. So I propose that we add to that interface a static abstract property to return the correct structure type enum member for that particular structure, and then rename the fix up method something that isn't just structure type, because that naming it structure type is not indicative of what it does. And also it's implemented explicitly on every single struct, which can just generally be annoying, because sometimes you need to work with it outside of the context where you're using it on a type parameter constraint to the interface.
Yeah, I think the explicit implementation was as a result of the terrible name and the fact that well, I mean, we're also getting the structure type, but we're also changing it. So how do we what are we going to call it? Get and set structure type. So I think it was a massive compromise in the 2.x proposals. I mean, there is probably an argument for no longer making it an explicit implementation, but yeah, I don't know. I mean, we'll discuss that in a bit. I suppose the most pertinent thing, I mean, with the base in and base out structure, those the reason for why they're two separate structures doesn't exist in C# because all of our pointers don't have const correctness, be it in the C# language or in the abstractions that we're going to discuss later. So fundamentally, it probably never made sense to use either one for these chain abstractions because a chain can go in or out. We did have discussions about deduplicating those structures. However, we want to stay true to the actual headers that we bind to, and deduplicating those structures into just like a base structure, for example, might be contrary to user expectations. As for the other stuff, like the pointers, the untyped head pointer feels like a bit of a on the nose name. It feels strange to have untyped in the name, but I can get why. That all seems fine. My main question is, with this proposal, do we have the ability to have chains where you don't know every single type, or, for example, don't even know the start type? And the second question is there even a use case for that? If none of that's impacted by this proposal, then we should have discussed whether there's a use case a long time ago, and we can just carry on doing what we've always done. But I'm interested to hear your thoughts on that.
Actually, a large number of reasons to have untyped structures here, and that's specifically because Vulkan is designed to be majorly extensible. You can insert arbitrary plugins at the registry layer. You can force extensions and stuff on. via various system config options on every single platform, and that's how, for example, RenderDoc ends up inserting itself into your program without ever having you make changes to your code to support that. And so one of the reasons why it is consistently typed in layout with a structure type as the first field and then a arbitrary pnext void star as the second is so that you can just say, if it's not null, then I can reinterpret cast it to this layout, access pnext, modify it to insert myself at the end or beginning of the chain, and then not have to consider anything else. You don't have to consider who else has inserted themselves arbitrarily. You don't have to consider what specific types are there, etc. It's meant to be abstract in that sense.
And in that case, then this whole managed chain type system falls apart because the entire core of these types is that they are for chains where you know the types and order of the members of the struct, and then the concrete object allocates and manages a block of raw memory that it then uses unsafe tools to basically it just takes the singly linked list and puts it into an array. And the whole abstraction, like in this case, for this particular one, falls apart in the case where the singly linked list has been changed or where you don't know various elements of it. Knowing the head of the chain, I think, is basically guaranteed because that is the parameter of the Vulkan function you're calling.
Yeah, because I think that's the main thing. And I think that was the main point in introducing the chain polymorphism in the first place was the fact that if you've got, like, for example, a chain of I don't know, device create info, you could add. I think we do provide functions that then allow you to add whatever structure to that chain, and that returns a chain of device create info and whatever type you've just added. But because of chain polymorphism, that then
for example.
Yeah, well, yes, and then because of the chain polymorphism, that is still usable as a chain of device create info, because C# is magic. So I think that is still possible. I think there's probably a line to be drawn because, well, I don't see any scenario where you don't know the head of the chain.
Abstraction over this. It is worth noting that there is also a different set of utilities over Vulkan structure chains that work directly on ref of the head of the chain and can be used to find items of a particular type or to add or overwrite items of a particular type to a chain working entirely on ref t head, for example. And those are all functions. The difference with those is that they are more flexible for chains that have had the contents or order changed by Vulkan internally, rather through a layer or through something core to Vulkan, because of them not requiring a specific, like that they're not working on a specific core memory layout, like how our particular managed chain types worked. And we don't really have an easy way to load a pointer to a head struct into one of these managed chain objects. And yeah, if Vulkans can mess with the order of the chain, I'm not entirely sure that the memory guarantees of these types are even valid.
Yeah, I suppose I think having completely untyped whatevers in being able to inject into a chain is probably dangerous. I think the line that we should draw is that any type that implements the the chain interface contract, so it implements this iStructured type, it implements iExtends chain and whatever. That way, when you pass it into these polymorphic functions that expect you to be able to operate over, like, for example, the size of the struct, we can still figure out from those generics what you're at, even if it's not part of the main Vulkan binding. Like, for example, if you made a custom layer, a custom extension exposed by that layer, and you want to pass your structs using the managed chain objects, I think that still works in this scenario, because it implements all the necessary interfaces. Why would our chain
yes.
polymorphism care?
It does work like that, yeah. The main issue I can see is if something internally adds a new element without the calling managed code knowing about it, which I'm not sure
I think that's
how
illegal.
Vulkan would be able to do that from a memory perspective without leaking it.
I'm not sure if I'm misunderstanding what you said, Perksy, but I it's not that like you don't always control all parts of the chain. I think Tanner mentioned before that the system just kind of gives you extensions to Vulkan, and you have no control over that really. So it's not inconceivable that there will be parts of the chain that just come from just like from your perspective, they just magically appear after you call some function. And so assuming that we can statically type the whole chain isn't really correct, because we sometimes don't even know, or sometimes we can't even really find out what the type of some part of the chain could be. So I don't think that's
Yeah, so
Right.
the managed chain classes do fall apart somewhat as a result of that.
Right,
Yeah,
the-
so I
the-
think
I linked in chat to the doc, but basically there's this whole thing of implicit layers and implicit extensions that Vulkan has, and there's a page for every single operating system on how it works. And someone simply defining a VK layer settings.txt file and putting it next to their app can allow arbitrary layers to be loaded and therefore to change the chain. And then, of course, since it's now arbitrary code running, you can go and insert yourself at any point in the chain. You can even remove someone else's layer from the chain. And, there's best practices and there's things that you're supposed to do and not do. But ultimately, this is how Discord layering works. This is how Steam overlay works. This is how RenderDoc plugs in so that you can do diagnostic debugging of your GPU pipeline. You really have, other than knowing that a particular pointer won't change, you have no way of guaranteeing that a particular chain will always statically be that chain.
Yeah, so I think Vulkan is a lot more inconsistent here than OpenXR, because OpenXR, I remember when I was working with it, you actually have to go through and fill out all of the S-types for all of the output chains, and it is completely illegal in that API for the implementation to insert new chain S-types, for example. So it can't give you a pnext that you haven't explicitly asked for. Vulkan is inconsistent here. If you don't provide an S-type, for example, it will fill it with the most appropriate thing for that given context. However, I don't know how consistent the new stuff is with that. So I think, given that OpenXR has done a better job here, in that it enforces that you can't inject arbitrary pnex, and while Vulkan it is technically possible, it realistically likely follows the same best practice, but sometimes it doesn't. Maybe. I am content. I'm content with this abstraction falling apart.
It's worth noting that the issue of whether the pointer properties on our managed chain things are untyped or not, the managed chain objects also expose a ref t and a value get set t for each element in the chain. It's just the pointers that are inconsistent and untyped.
Yeah. Okay.
The way I view it here is kind of that what you're trying to ask for is a strongly typed chain, but in practice what you have is a list of object, and you kind of have to do that same base type check. And so what I would think that the right way to do this is, if you want to have it quote unquote strongly typed, it'd almost be better to define the core base interfaces that every struct has, just the first two fields, and have pnext be a chain of those. That way users can do the if object is type, which for Vulkan is if obj.type is X, then they know how to handle it there. Otherwise, move to the next one in the list. That's ultimately going to be way more robust and better fit the actual model that exists.
Yeah. The main thing with our managed chain objects, at least as far as I understand it, is to some extent a lot of what those objects were for is less to do with strongly typing and more to do with memory management. So you don't have an ridiculously big nested fixed after fixed after fixed that goes like however many lines deep for each item in the chain, that you then have to do as many lines assigning pnext in your code before calling Vulkan, and that just gets messy real fast as far as code cleanliness goes. I think that's probably the biggest use case for this. And again, it is worth noting that we have other utilities for working with chains directly rather than using this, in addition to just, we expose the unmanaged fields and stuff. You can just do it yourself.
Yeah, I think generally this is probably fine for the ideal case where you're creating a chain and passing it around whatever libraries you have internally, and then you're then collapsing that chain down to the final form as input, and you're not using this API to get the outputs, for example. Because I'm willing to bet that most people use the managed chain abstractions, if they use them at all, for inputs and not outputs, because it probably doesn't feel natural if you're using it for outputs anyway.
Or in my case, one thing that I use it for quite often is I'll use it to, because a lot of stuff, especially with the getting properties out of objects, because of the best practices, Vulkan doesn't add stuff to the chain automatically just as a best practice. So I have to include the extension objects with the properties I want to have filled in. And I don't really care if other stuff gets added to the chain as long as those objects stay around and I know where they are. And I use it extensively for that as well.
Yeah, fair. So I suppose on this, on the actual proposal items, I'm fine with the. Yeah, so I'm fine with adding the head pointers as the types. I'm generally fine with getting rid of base in structure. The untyped head pointer, it does make me raise a little bit of an eyebrow, because, well,
there was an alternative design available for that particular bit as well.
Yeah, so and that might make more sense, but because particularly if we're making the argument here that, well, this abstraction is only golden for inputs, then maybe we should use base in structure if that's what we're going to use most of the time. And those people that do want to use it for other stuff that is perhaps questionable and could break, well, they would be explicitly opting into that by using base out structure or whatever else, or they could just completely ignore the fact that it's an in structure and just treat it as a base structure. But if we want to enforce the use as an input, or at least make it harder to use as an output because it's possibly dangerous, then perhaps not changing that base in structure. But then again, your alternative design, I'm happy with as well. So I'm open to discussion there. Everything else looks fine.
Yeah, I think considering things, the alternative design was the alternative rather than the main design, as it involves more type changing rather than just changing the signature of a property or two. It requires renaming a type and adding a generic parameter to that type, which is a bigger change, which is why I listed it as the alternative. But in general, I think it may be the better option, just for general clarity, and as a result of our polymorphism here, like the one thing that hasn't been implemented yet and hasn't been proposed yet that I intend to work on for a future working group meeting is that currently we don't have any functions that work with the polymorphic chain interfaces, whereas what we could do in the future is have a function that takes a pointer to the head of the chain and creates some sort of polymorphic chain interfacing. You don't, with less guarantees about like what else is in there, because we have those interfaces now, whereas before there was no way to treat two chains that have the same prefix as the same, like in the same way. So now that we have the polymorphic chain interfaces, it may be worth in the future looking into ways to extend use case of that and prioritize treating it more dynamically as you load the chain, and this abstraction then creates a chain object that is correct for the state of the chain as received from Vulkan, and then you can use like standard .NET type checks and stuff or other functions to interact with it in a strongly typed way like that. So it may be worth revisiting this in the future for a future meeting, but yeah, I think the alternative may be the better option here based on this discussion.
Yeah, that's what I'd say as well. I think everything else. I mean, so I suppose the only other thing, everything else looks fine. The only other thing that I could possibly discuss is the fixed structure type strategy. So I suppose. I mean, we've got loads of lovely C# features we can use now. So why don't we make this instead of having fixed structure type, we've got this static abstract. We've got oh no, because you can't get a static abstract through an instance. Okay, yeah,
Nope.
never mind. This is fine. I was going to suggest.
I hate that, but it is nonetheless true.
Yeah, because what I was going to suggest is having a S-type ref property in here, and then just allowing the caller to assign structure type to that ref property. But that doesn't work because you can't get without knowing the concrete T, you can't get structure type. So that's unfortunate.
Yeah.
So yeah, everything else looks fine.
Anyone else have comments or thoughts about this?
Why is it called structured type instead of typed structure?
An excellent question, Tanner. We
Yeah,
probably should have discussed this when this was originally added.
Yeah, that is a name from before I knew Silk existed.
Yeah, so I suppose we could change that if we wanted to. 3.0 is the opportunity for us to make these sorts of changes. However, I'm personally against making benign breaking changes. Not benign breaking changes, sorry. Breaking changes where the existing way of doing things is benign. So we could change. I mean, we could change the name, but fundamentally, everything else is still going to be the same. And to be honest, most users probably don't even bat an eyelid at iStructured type, the name of it, when they're writing code. So I think leaving it as it is won't cause too many issues. At the same time, there's probably not a lot of users that use iStructured type directly, and they just treat it as some magic that makes the chain abstraction work. So we could make an argument for changing the name based on that. But generally with these sorts of things, if there's nothing gigantically sticking out like a sore thumb wrong with the existing way of doing things, I generally tend to prefer familiarity. I know this drove Kai absolutely nuts when we were originally designing 2.0.
I mean, I think 3.0 is already going to be an absolutely massive change. I think it might be fine to do needed renames, even if it's tiny and like not really necessary, like I structured type versus I typed structure. I think it would be, at the very least, the correct change to do, given so much else is going to be changing anyway. We might as well fix some long-standing weirdness since we have the opportunity to.
I'm good either way on that particular point. Yeah, I don't know. I'm good either way.
I mean,
I type structure makes more sense, but it's a breaking change, so I'm good either way.
well, we can put it down to a vote, I guess, because I don't think any of us have any solid opinions on it.
I barely use Vulkan, so I don't have too many opinions on this proposal.
Right. Well, sorry.
Kind of my view here is you're making a breaking change to this type anyways, one where users will fundamentally have to go and change their source code. So
Yeah.
if you're doing that, then if you're making users have to touch this type anyways, then it becomes almost simpler to
and most users won't have to touch this type.
To take the break, to fix it how it should have been, and then provide, if it's really problematic, provide a refactoring. But most people probably won't be implementing this in a way that's meaningful, so it probably won't impact most people anyways. So the risk is low.
Yeah.
Okay, cool. So I'm with renaming it. We should probably bike shed the proposed name this time around. I typed structure.
Yeah.
A structure is a type, isn't it already typed?
From the C# perspective, yes. From the Vulkan perspective, no.
Not without defining the members that I type structure or I structured type, whatever we want to call it, implies. My original thought would have been I chain member type, because it is the existence of these fields and the contract that this interface implies, even if it can't really easily define it because it needs to be because it depends on field layout. But part of like the contract is what makes a struct able to be participating in the chain abstraction. So I chain member type makes sense to me. Thoughts?
Hang on. Vulkan has a name for this. Why not I base structure?
That's a very good idea. Take our cue from the thing we're binding to. That makes sense.
Yeah, that's probably the best option to match the upstream name.
Any objections? All right, cool. So, any more on this proposal? Otherwise, I will post these comments, and I'd say we can just approve this once the comments are addressed. I think we're in agreement in what needs to be done here. We're going to go with the alternative design. We're going to rename the structure, and everything else looks fine.
All right. And we can always revisit this in the future if we need to.
Yep.
Okay, cool. I shall post those comments.
All right, what's next? Oh, next up is Perksy's proposal. The big one.
The big one.
Big one. Well, we've got 19 people watching this stream. That's more than we've ever had for this. They're in for a ride. This proposal is essentially proposing 3.0. So, where do we even begin? So there's a bunch of background information that I'm gonna skim through. If you want the full scoop of what led us here, then do read the Markdown proposal. It is linked in the YouTube description or the Discord Help Wanted channel. But basically, when we originally chose to go with API objects in 1.0, actually back when Jax and I were developing OpenTK 4.0, it was because when you look at things like, well, first of all, it was an implementation detail because that's how Jax's advanced dynamic loading library works. But second of all, it also made sense from an API perspective because the OpenGL functions are inherently stateful. They're tied to the context that that object was created with. For example, if you weren't using the abstractions that OpenTK provided, then you would have to go manually. I believe it back in the day it was called toolkit.init, so you'd have to manually call toolkit.init with your getproc address or whatever. I believe in the new versions of OpenTK, that's gl.load bindings, but that is fundamentally storing state that is tied to a particular object in a static object, which, I mean, I don't know whether I've spent too much time with Rust, but that just rubs me the wrong way. So we made the we made the decision early on to stick with this API objects model that was brought upon us by the ADL library. And this carried on through 2.0 when we were introducing SilkTouch. We basically just replaced all of the abstracts methods that were implemented using system.reflection.emit and changed it to partial and had our source generator go over it. And that, for the most part, that works really well. However, it kind of broke down when we started adding bindings to things that to functions that were not inherently stateful, like DirectX, for example. So because people essentially have to make an API object for no reason. So there's problem one, or background problem number one. The second problem that this proposal aims to address is the portability of the generator. So build tools is what currently generates the bindings that goes into SilkTouch. It generates the API signatures. It doesn't generate all the actual DLL import or function pointer invokes. That's all done by SilkTouch today. But one thing that's noted, because I think Bailey, you've used build tools outside of Silk.net a couple times, and I think you can probably agree with me in that it is not it's very build tools is optimized for Silk.net usage. Is that fair to say?
Yeah, trying to beat it to work with anything else is extremely difficult. It's possible, but it's not very maintainable.
Yeah. So if you look at other generators in the scene at the moment, you have Tanner's wonderful Clangsharp p-invoke generator, which is very generic. It's got some TerraFX specific stuff in there, like you can have the transparent Win32 handles or transparent Vulkan handles, but for the most part, it is taking a C header and making it as close as humanly possible, as if you were just be able to do includes like Windows.h, for example, in your C# code. Everything's C#, everything's C named, everything's raw pointers, and it basically just takes the header you give it and generates a one-to-one mapping of that in C# land. And the benefit of this is that it is wonderfully portable. You can use that in literally any project. Although TerraFX is the main use case from a first-party maintainer perspective, there's lots of other there's a lot of other stakeholders in it. For example, Microsoft use it for their Win32 metadata. Countless other projects use it. I think ZooFX's CPP AST.NET uses it now. It's completely generic. You can use it anywhere, and that's a note that we want to take, because there's a lot of situations where users have come to us and say, "Hey, you're going to make bindings to this," and we say, "Well, no, because it doesn't go with our principles of binding to open standards that are maintained by a notable industry body." Which is generally our threshold for adding bindings. Whereas if we had a generator that you could use outside of Silk.net, we could go, no, we're not adding bindings to that, but here's an easy way where you can make your own bindings for it, and just provide some instructions, and it just works, in theory. That's not to say that there won't be complications, but because these generators are quite. I mean, doing anything with Clang is finicky in the best days, like getting all the include paths, right, or whatever else. But it will be a lot more usable, and fundamentally, what I've wanted from the start of 3.0 development is to make a generator that is usable outside the project and that is actually documented for such usage. And build tools in its current state fundamentally cannot be changed into that model because it's too far gone. So that's problem number 2, and problem number 3, and this is really the crux of what I think most of our discussions will be, is the fact that build tools generated a lot of overloads. I think we've had situations where one function has had 2 to the 16 overloads. We've probably
3 to the
had
11 is what I've gotten.
3 to the 11. There we go.
3 to
We've
11
beat
is what
it.
I've gotten. It was ridiculous.
So yeah, and this was great. Again, this comes back to the fact that we made a generator for OpenGL, OpenCL, the Chronos bindings, and we decided to throw that same generator with just a little bit of a Clang backend that mostly would beat the AST into the object model that was designed for OpenGL, and just expected it to work fine. And this became very problematic very quickly because we have loads of functions with that would try to generate ridiculous numbers of overloads. Or I think we even shipped an async function that has like 150 overloads or something ridiculous like that. IDE experience isn't completely terrible here. The IDEs don't like it, but I mean, the good ones like Rider do start filtering down overloads as you type, as it gets more concrete typing. But it's not the nicest experience in the world. So we're going to be attempting to address that with this proposal. Yes, so this is a go of some of the history of how we got there, because originally we didn't generate every single permutation of overloads for a particular function. We would just generate like layers of styles of overloads, but we got complaints pretty early on that this didn't give enough overloads, or if a user wanted to use a string overload, for example, they'd have to suddenly revert to using raw pointers elsewhere, and generally we couldn't make this in a way that would please everyone, which is what we want to do. So again, I mentioned it briefly at the start of this stream, but 2.0 blew up recently because of the libclang bindings, so which prompted me to start SilkX, or Silk Experiments, Silk Experimental, whatever you want to call it. It's basically my attempt to make a generator that has as little code as humanly possible for us to maintain, so we can delegate that to the people that actually know what they're doing and can consistently maintain a generic solution. Sorry, Tanner, but but we're using your expertise there, because because we did have a lot of issues in the 2.x development cycle, wherein we had a bunch of functions that were not bound to correctly, be it because of particular calling conventions. I think we struggled with the CPP member function, for example, or because we just weren't mapping types correctly, that we have incrementally fixed, and it's to the point where 2.x is pretty usable now. Dare I say, nicely usable, but it's a lot of maintenance effort that we wouldn't have had to undergo if we were just using a known good foundation for that. So SilkX, in particular SilkTouch X, is basically just the minimum amount of code possible to take raw output from ClangSharp p-invoke generator and lifting it to be silky and usable with loads of wonderful types. We did discuss this informally in one of our coffee and code meetings, which I know a lot of people don't show up to, but those are basically our impromptu catch-up sessions that we do on the .NET Foundation channel, and they are enlisted afterwards, but you can find them all in the Silk.NET playlist on the .NET Foundation channel, where we basically said, like, where we basically discussed the overloads, the alternative to overloading that I'm going to propose in a second. So yeah, gone over ClangSharp. And our alternative to overload for the purposes of this proposal is essentially when you look at span, our bindings use span, but you can pass an array into it. It just implicitly casts, and you can likewise pass in other stuff like I think memory T or whatever else. But basically, users use that model already. Why don't we just take that to the extreme, and that will solve our overloading problem? So that's essentially what we've done. So any pointer or any ref that we would otherwise generate instead goes through this reft or ref2dt or ref3dt, and the same for pointers, raw pointers that aren't ref tracked. So that's in like the return position of a function, for example. That is implicitly castable from a string, an array, a raw pointer. So if you've got those unsafe purists out there, which I know there are some people that do that, you can still pretend that these are just raw pointers and signatures. Fundamentally, it's more flexible without bloating the class with loads of differing API signatures and making the IDE experience terrible. This IDE experience is questionable in other ways, in that while in my experience Rider does know what can be implicitly casted, it's not immediately obvious when it's coming up in your autocomplete that that's what it's doing. But I mean, I'm of the firm belief that we could probably just document all of this in like a single page, probably maybe even a single paragraph, and that would be enough to know how, basically just to get to know how we do these bindings. I think these names are sensible. So we did, when we were trying to do const correctness, the names very much weren't obvious what they were doing, because we tried to track the all of the mutability combinations up to 3 dimensions, and it would end up in being a pointer mute pointer, or a mute or a pointer pointer pointer, and you don't know which dimension is mutable or immutable, because you don't know whether it's going left to right or right to left, for example. So we decided to take one from the C# language and just not do any const correctness, because the C# language doesn't do it. So if you're using raw pointers, you wouldn't be doing it either. So let's just keep with that model, because trying to do const correctness was more trouble than it was worth. So this proposal goes into details about what these pointer types will have. If you want to know the specific APIs that we're proposing, unless inappropriate, we basically the crux of it is like anything that you could conceivably use in a pointer position, be it with manual marshalling or it just being directly castable using a fixed or whatever. We aim to be implicitly castable from that. So you can pass in an array where there's a pointer of t. You can pass in a array of t. That also applies for jagged arrays as well. And I'm not sure if we've got multi-dimensional arrays yet, because they're a particularly problematic case. But our aim is to provide a foundation where we can add a bunch more implicit casts in the future without having to add another overload, for example, or otherwise make the IDE experience worse and the user experience worse. And this has worked out really nicely. We've got a demo of a OpenGL triangle using these bindings, and I personally feel that it will please the people that absolutely hate unsafe, as well as the people that do like unsafe. And we've been discussing this for multiple months now on how best to implement these types, and I think we've landed at a good solution. Again, you can look at the specific APIs available in the proposal, but our goal is to make these types as usable as possible.
I have a question on how 2 scenarios are handled.
Go for it.
First scenario. You're saying you're taking a span instead of string in some cases. But in many cases, a string must be null terminated, and it is required by the underlying API. A span does not carry the information on whether something is a slice of a larger string or if it's null terminated. So how is that handled? And the other question is, there are many APIs, especially in Win32 and the Linux system APIs, where something says it may take, for example, an LPCW string, but functionally it is not always a string. Sometimes it's an atom, and so therefore taking a span of characters for let's say X may not be valid because that would be incorrect when it is in fact instead a an atom returned from register window X or register class X. So those two scenarios.
So scenario 1, I would probably so if you have a span and you try to implicitly cast it to this ref type, we will just assume that you've done everything correctly for the particular API because you're giving us a pre-marshaled span of bytes, for example. So we will assume that you've got that little 0 at the end and that'll make it all happy. If you pass it a string, we will do that for you. It's like a layered, like how comfortable are you with dealing with the underlying API constructs? So scenario 1 I think is covered. Scenario 2, that is a bit trickier of a case, but I assume in that case, so we do have an untracked variant of this ref type that is PTRT, PTR2DT, PTR3DT, that we use in return position by default. So if you get, basically, whenever you're getting a pointer from unmanaged land, you can you can use this PTRT and store it, or you can use a raw pointer if you're not afraid of that. And the idea is that you can create, and if this isn't possible already, it will be possible. You can create a ref2dt from a ref PTRT. So you can, so if you've got like an atom or some other opaque thing, then you can just take a ref to a pointer of that or a ref to that and pass it down. I'm not familiar with the specific scenarios that you're referring to because I don't have encyclopedic knowledge of every single function that we could possibly ever bind to. But I have a feeling that based on the fact that we have both tracks and untracks, storable and unstorable, and the ability to use one from the other, that those scenarios should be addressed.
Okay. Just to give a little bit more context on the second one. So Win32 is probably the easiest example. There's an API register class X, which you have to use to register things like your like the callback used for all of your windows before you end up creating even the first window. It's basically saying, here's my window type. That returns an atom, an ATOM, which is a 16-bit integer. Then there's an API create window X. That has a parameter, which is LP class name, and that is allowed to, and that is always typed as LPCW stir. So it's always a constant wide string. However, that pointer is either a valid pointer greater than 65k that points to an actual null terminated string, or the pointer is a value between 0 and 65k. 0 is of course null, but any other value is one of these unique atoms returned by by register class. And so you can literally take this atom and reinterpret cast it to an LPCW stir and pass it into this other function. So it's effectively dual typed in what it takes. And the range of the pointer determines what it is. Because values between 0 and 65k are treated as null by the underlying platform, this ends up being safe because it can never conflict with the real allocation. But that also means that if you're trying to interpret it as an actual ref to a character, you can end up with undefined behavior for otherwise valid inputs, especially when looking at things like the debugger, because the debugger and stuff will only treat literal null as invalid and don't dereference it.
My good God, that's terrible.
Windows
oh
isn't
God.
the only one that does this either.
Oh.
Lots of older APIs across all kinds of platforms do various tricks like this because they were trying to save space. Back when a gigabyte hard drive cost you $1,000.
Is that legal? That kind of API will that get you arrested? That it should.
Oh, you got a license for that API?
Okay, that is a very difficult situation.
Yes.
It feels a bit like this OpenGL function, GL text image 2D, if I recall correctly. There's a border parameter, and the documentation says this must be 0. You can't specify anything else. It must be 0. But good God, this is just so much worse.
Yes.
I think it's also worth noting, I don't believe, Berksy, you mentioned this, that we have a singleton type that implicitly casts to the null pointer. Because unfortunately, their unsafe null ref is kind of terrible to use for this sort of thing. But if you need to pass a null pointer, that is handled. As for the other cases, God, I don't know how you put it. Into this.
Yeah, so I guess fundamentally that atom thing is an example of pointer transcendence and then reinterpreting the transcended pointer to the actual pointer type, which is pretty damn unsafe. One could almost argue it's so unsafe that you're better off using the raw pointers and knowing what the hell you're doing. Which, again, is possible with this abstraction. You can use raw pointers and just pretend that that the parameter types are raw pointers and all of the implicit casts work fine.
So the concern with an implicit cast there is you're taking something that isn't null, but which is valid, and converting it to what is functionally a ref struct tracking a ref t under the covers. As soon as you put that in the debugger and you start single stepping through it, you're gonna run into problems.
Oh, is it the tracking that you're specifically worried about?
Right, because the debuggers and tooling typically special case literal null, as in 0, versus everything else. Even if the underlying system will technically treat values between 0 and 65k as null, most systems only differentiate literal null from the others. So once you start debugging, the debugger is going to do things like, oh, I have a non-null ref. Let me go and dereference that to see what's actually there. And then you're going to blow up the world.
Yeah.
And with it's one of those things where it almost seems like the better scenario is to expose what is functionally a purely unsafe pointer overload. That is the raw pinvoke that is compatible with disable runtime marshalling. And then a secondary overload, which is the fully safe overload, which would be the one that takes all of these ref types. So everyone becomes 2. The one that's 2 always defers down to the blittable one. Then you don't have to worry about these things, because you can just tell people, if you're going outside of the normal like valid scenario, use the pure unsafe one, which you functionally need anyways, as your raw pinvoke.
So real fast, the worry here is that the atom being returned to you by a function could potentially be dereferenced because it's not, and be a bad dereference because it's a null pointer. Is that correct?
Because it is an integer because it is a integer cast to a pointer that is between
Okay.
1 and 65k inclusive.
So here's the thing. Atom being returned to you is not going to be returned as the ref type. It will be returned to you as the pointer type.
No,
It's
that's not. That's
storing a ref.
so. An atom is defined as a word. It's not a pointer.
Not
it's
a
a
pointer.
U short.
Then
It is a
shouldn't
U
that
short.
just be returned to us as a U short?
Right, but then a
not-
user has that and they want to call create window X. Create window X with the proposed will take a it sounds like a ref character. In which case the user does the conversion, an explicit conversion because it's not one implicitly supported. Because they want to do the faster thing. Because it is significantly faster to use the atom directly than to require the system to parse the string, do a table lookup, and then get the underlying atom.
Okay.
They're debugging through that. They step into the function, and then the debugger crashes because it thought it had a valid ref, and it tried to load it and view the value for you.
Isn't there debugger like there isn't there an attributes and stuff that you can use to say debugger never look at this, debugger browsable? That's what I'm thinking.
Well, the thing is that you would want the debugger to look at it in other situations. There are reasons for the debugger to look at it,
Correct,
and
yeah.
I can confirm Rider and VS, full fat VS and Rider both have this issue where it will just bring down the whole app if the debugger tries to dereference a bad pointer. I've experienced
Yes,
this
I've had
before,
that.
so this
I've had that in Clank Sharp a lot.
Yeah, I'm sorry.
Yeah.
I've tried to fix those, but it's kind of the same problem there. And
Yeah.
except over in Clang, it's because libclang actually does zero validation under the covers. They just
Not.
they just take everything you give it and use it directly, and they're like,
Oh.
if you're not using it right, good luck.
Of course, they don't
lovely.
do any validation.
Okay, so this is a particularly tricky scenario. I agree that it probably makes sense to ensure that we expose the unsafe overloads, like the raw pointer
That's
ones.
still only two.
Yes, exactly. That's two overloads. I can live with that. And to be honest, that would probably make some of our unsafe purist users like Skybird happy, or Petri
Yeah.
Griffon as is now known. They're now known.
Reformed.
So
Yeah, that's still better than 3 to the 11 or whatever that was.
yes, exactly.
Yeah, 311
Exactly.
was I think something in Wick or Direct Draw, something to do with Windows fonts. There's a method which had 11 parameters, each of them with 3 permutations, and just it took 11 minutes to write out the file, and it was like 30 megabytes of just C#.
I think Curin was the first one to discover this, because when I was attempting to add Direct 2D bindings, I just assumed that the generator got stuck in an infinite loop somewhere and gave up, whereas Curin actually left it run for a while.
Yeah,
Either way, 2 overloads to
and it
include the
was
unsafe one is
still
better
very
than that.
upset from what I remember. If I remember specifically, Build Tools was breaking at a point because it physically did not want to store that many overloads.
Build Tools using like 11 gigabytes of RAM in my VM, and I just went and got a glass of water, and then just waited for it to finish, and it eventually did, and it was ridiculous. So yeah, I think 2 overloads is going to be a very reasonable. I don't think
that's
we're
going to be
run
quite
into
trivial.
any-
Yes.
I don't think we're going to run into any 20 megabyte C# files with that.
Another thing that just might be a smart change to make to the to the ref types is to not allow them to have them throw an error if they're explicitly being handed something that isn't a valid pointer. Aside from null ref, or to push it down to 0 if it's in the event that we are given something like
So
this.
I guess one way we can mask the problem is implementing a custom toString that just does the same thing as a raw pointer would do, for example. It doesn't implicitly deref, but that doesn't stop the debugger having a peek inside and dereferencing that ref anyway. So that's
Yeah.
one thing we can do. But yes, I think generally this will be solved by having unsafe overloads as well, and just trusting
Yeah.
the user will do the right thing.
Yeah, think about it. You can introduce a like debugger, like there's a way to introduce a different type that is used as the debugger view for a type, and we could have one of those that then validates and treats everything else as a reference to a constant integer maybe, or just as null. And
Not
then
sure
There
those
is-
entirely work with ref structs.
Yeah,
Right,
there is
ref
also a
structs.
concern of computers are very weird, and it is entirely possible that in some cursed horrible scenario that it may be what looks like an invalid pointer but is valid because of some horrible things that are happening under the hood. I don't feel like implicitly trying to crush down anything less than 65k to 0 would be a good idea. I feel like the best option is just have the unsafe overload, and then just have people who need to use an atom type, like in the case of create window ex, making people have to use the unsafe overload. I think that's definitely the preferable solution, at least for me.
And
good with that.
even if you have a debugger display attribute and it's working with ref struct, both Rider and VS have this debug option of show me the raw layout regardless, and then you can
Okay, yeah, so that wouldn't work.
you can always expand and see it.
Yep.
There's a
I-
bunch of safety tape that we can put on it, but ultimately the problem will still be there.
Yeah, and then it's a question of like, is the overhead worth it versus basically telling users don't do this, use the unsafe one overload if you're looking for that absolute performance that these kind of special tricks get you.
Yeah.
I also wanted to touch just briefly back on the first one. I'm not sure the scenario was entirely understood. So the scenario wasn't that the user is creating a ref themselves to pass it in, but rather, for example, the user has a read-only span of characters that they had sliced out of a bigger string. Because of how it sounds like ref is going to work, either string or read-only span of character would be implicitly convertible to ref of character. But if the underlying API requires the string passed in to be null terminated, then you can statically determine it to be correct with string, but not with read-only span of character. And then that also applies to read-only span of byte, which is the only type for UTF-8 string literals. So you have no way of, even though the compiler will null terminate the actual literals, there's no way to determine if it is an actual literal or if it's a slice and therefore not null terminated. And that will potentially lead to accidental user bugs where they think passing in a span is correct or safe, but it's not because it's not null terminated.
So you brought up a particularly something we probably haven't considered particularly. So for string marshalling purposes, if you give us a string, we will implicitly create a temporary array containing the native representation, including that null byte, and all is right with the world. For read-only span, so a span is castable to this ref type, but we assume that it's not a string, that it is in fact an array or an array-like, and therefore we will pass a ref as is, even if it isn't necessarily valid, which isn't necessarily what the users want. You're right, and I hadn't considered that, because if you're passing in a read-only span of char and you want it to be a string, then we're not going to go through the string marshalling path. We're just going to assume that this is a char pointer, and you've given us something that looks like a char pointer, so our job's done here, which isn't true for string likes that I'm going to call them.
Yeah, and it's something that I don't have to worry about in Terra effects since I only expose the unsafe overloads. But once you start exposing these safe overloads, it becomes that question of like, well, what subtle issues will a user hit if they think passing in a read-only span is correct, but it's actually not, and there's an additional limitation that can't be tracked.
Yeah. Kieran, do you want to help me out here? I really don't see an easy solution out of this.
The thing is I also do not see an easy solution out of this, because there are cases where this is a problem, because essentially we could be passing in something expected to be a read-only UTF-8 string. Let's go with UTF-8 string because this one's the most murky. And we expect that they've passed us a correct thing. The thing is without knowing, which is something really the generator can't know, but without knowing that it's expecting a read-only string, there's no way to check. There's no way to see if like this function expects a null terminated string. And the thing is especially with C strings, what if they're not expecting a C string? What if it's just expecting a byte array? There's no way for us to know that on the binding side, without going painstakingly and having some way to mark each method. Some bindings we might be able to know that, but I don't think we'd be able to know that universally. It would kind of come down to either we're fine with saying that this is one of the parts of you're using unsafe code. There are certain things that you need to be aware of how your bindings react to certain things and what they expect. Or we don't allow it at all, and they still have to go through and know what the binding expect, because if they take and just try to marshal a string without doing any of the work to add an alternator onto it themselves, they'll run into the same issue. It's thing here is there's no way to foolproof never hit an issue. We can just either provide a tool and say sometimes it breaks, or not provide the tool and say it's kind of in your own hands to deal with this. I don't really see another way around that.
I think saying the completely unsafe pointer overload is in your own hands is always fine. They're dealing with raw pointers.
I'm not saying that that's a bad choice to go. It's just that then we are depriving them of a tool that is useful 90% of the time.
Right. And that's where the safe overload, I don't think you want to be in a world where you say this looks safe but it's not actually safe. Or it's only safe like 90% of the time, because users can get into the bugs. And what I would end up saying is the best thing is to do what the built-in marshaller would have to do, which is effectively there's going to be overhead, but you have to allocate an underlying. You can basically shortcut by saying if the span actually ends with a null terminator, pass it directly, and otherwise.
So here's the thing that's an issue with that. How do you know that that this function expects a null terminated string?
Right, and you can't do that without analyzing something like SAL annotations, or analyzing something like the actual Vulkan spec as to what it's requiring there.
Yeah, but this is also a bindings generator that we're expecting other people to utilize. What if they are binding to something where those annotations aren't available?
Yeah, the only even mildly decent heuristic you could use is there a count associated next to this pointer? If so, then it's probably not null terminated, else it probably is.
Yeah.
But there's also the concern of you can't really know whether something is a string or just some arbitrary bytes in C because it's all just char star. So there's not really a way we could really know for certain whether something should be allowed to accept strings or not.
Right.
We'd have to either have users, like users who are using generator, specify either on a global setting or just on a per function basis whether some function makes sense to accept strings or not, and that just isn't really easy.
Yeah, and then you have cases like create window X, which take a string or not a string.
Yeah. But I think that's
So
what
I
gets
Also,
us
is
covered
there a
by
way?
unsafe.
Is there a way where we can check if a span is actually null terminated? Like we can't just read the next
We
byte in memory.
could, but
You
the thing
can't
is we
read the
don't
next
know.
byte.
We don't know if that's even a valid thing to do, anyways. Even if we do it, say you find a way to go through and do it, it's not always
Yeah.
necessarily a valid assumption to make, and we
We
have no way
have-
of knowing when it's valid and when it's not.
We have a special struct in the BCL test library called bounded memory, where it explicitly uses native APIs to allocate a page and then return an allocation where the next byte past the end is invalid. It will cause an AV because the page is inaccessible, so that
Yep.
we can validate users aren't accidentally reading past the end and causing buffer overruns.
So I have words here. I think you're right that we do need to probably introduce some sort of implicit behavior for the final 10% of that of the use cases for this. I think given that string slices are always read-only span of char, we can probably special case read-only span of char and say, well, we know it's read-only, so in theory, native isn't going to give us anything back. So we can implicitly create an array with that null terminator and pass a ref to that instead. It's not pretty, but it will have an implicit fallback for that 10% of the cases where it otherwise wouldn't work. And if you don't like that, use an unsafe overload.
I think it's also important to also do a byte, read-only byte array, byte span, because that is what we can get from a UTF-8 literal.
Are they? Do we have a guarantee that they're null terminated? Tanner, you'll probably know this.
But
I
what
don't
if they
think
take
so.
a slice of
Also,
it?
like what
So-
we're like, there's a difference between what's the type parameter on your ref and what's the type parameter on your span. Like what the way we have it now is read only span char converts to ref byte because that then would invoke like some sort of, or like I don't know if it does in that case, but string converts to ref byte. So like if we're getting a read-only span byte, I would say that for the most part, if you're passing something like that, I would expect the only case where this would really interfere be the read-only span char, because if you're already working with bytes directly, it's expected you know what you're doing. I don't know.
Yeah, this is an extremely tricky one.
Is that safe if it's a ref byte, because then it doesn't track a count, and if it doesn't track, or I guess it is safe because it doesn't track a count, and so you don't have the risk of overflowing. There are notably platforms, Risk 5 is one, where the sign of the type matters, and so passing in a int where the underlying API takes a uint, for example, will break the calling convention of the underlying platform, and that may be something to consider there on whether type mismatches are okay or not.
So in this case, if there's a type mismatch there and you're converting like a string or a read-only span char to a ref byte, that's telling our marshalling stuff to convert to UTF-8. Like our string marshalling uses the type parameter of the ref it's converting to determine what width of character to use.
Yes.
So if the underlying API takes a char star in C, then you would pass in ref of byte.
If
But
yes,
but if it took a W char of T on Windows, you'd pass in a U short.
or a char, either way, they both convert the same, and our string marshaller automatically allocates an array, like allocates memory and returns a ref to the first element of the array, which then the garbage collector can handle, and knows about. At least as far as I understand. And then yeah, so if the thing takes a char star, then our thing is ref of byte, and if you pass a string to that, the implicit conversion there allocates a byte array and writes the UTF-8 of your string to that byte array with a null terminator, and then returns a ref to that so it can be garbage collected later.
Yeah, there are lines
I
to be
think it
drawn
uses,
everywhere, I think.
Array pool to rent out a temporary buffer because UTF-8 lengths.
So I think you are right in that it is in theory applicable to bytes as well. However, a string, string literals is possibly the only use case of that. Primarily because, well, strings, unless you're manually encoding that string, in which case we would expect you to manually add to that 0 null terminator. You can't implicitly cast a string to a read-only span of byte, and as a result, UTF literals is the only thing that we need to worry about.
And those include the null terminator effect.
They do include the null terminator. We've confirmed that. Okay, so in which case, yeah, I am still content with just special casing read-only span of char, for utility.
And you'd basically tell users if the underlying API takes UTF-8 and you want to use and you've manually transcoded the string yourself, you're required to ensure the null terminator exists, such as if you had sliced.
Yes, exactly.
Yes, because slicing a UTF-8 string is all another thing anyway, because of you can have variable bytes per rune in the string.
Right.
So if you're doing that manually, you're doing that manually.
And then you'd similarly say that if the underlying API only takes an ASCII string and the user passes in a UTF-8 character in the or passes in a proper Unicode character, then it's on them to make sure they don't do that.
Yeah, at the end of the day, this is largely a conversion. Yeah, this is overload mitigation, I think, at the end of the day. Like, we try to make it as safe as possible, but these types, at least as to my understanding from reading the proposals, are mostly meant so that anything you would want to pass converts unless we don't generate 3 to the 11 overloads for things. Whereas in previously we'd have overloads accepting span, string, ref, out, whatever the case may be, in addition to the raw unsafe one. Like, obviously we'd like to have this be as safe as possible, especially for marshalling conversions like with strings, but yeah.
Yeah.
Like, at the end of the day, we're not providing high-level validation and stuff for these low-level libraries or bindings.
I think in a world where we had SAL attributes for every single API that we will ever bind to that tells us exactly what we need to do, then we could provide more helpful things in that case. But in lieu of that, all you can do is provide things that are applicable for 90% of the time. If you're manually encoding your string, you should be expected to deal with all the pitfalls that come with that. Because I mean, you're manually encoding a string, so you can add that null terminator. For the case where you're passing in a UTF-8 char into an ASCII string, I mean, we will probably pass that down, because even where it's an ASCII string, we will do UTF-8 encoding because that's the most compatible thing to do. Again, in lieu of any other information that tells us what encoding to use. If that's not right, then you can deal with the implications of that. Again, it's as much as I'd love to make a one size fits all, we can really only do a one size fits everything that is probably sane in most use cases, and everything else I'd love to
Also,
provide stuff
attributes
that
on
deals
the
with everything else.
Functions don't apply to our types. Like, attributes and metadata on the functions we're binding to doesn't necessarily help with changing the behavior of an implicit cast to a type.
Sure, but
It is unrelated.
it's sort of unrelated, but also not, because if we recognize the sal attribute, then we could use that within SilkTouch to instead of using the general one size fits all ref 3D type or ref 2D or ref of T. We can just we can provide a specialized type. I don't know, like an ASIP string ref or whatever. That's just an example off the top of my head, but we could provide types that are more explicit about what they represent if we recognize attributes at the generation time. But that's just future stuff. That's not part of this proposal. Okay, so are we all happy with what we're doing? I think there are a lot of implications, and I think one action we're taking away is to special case read only span of char for string slices to copy it with that null terminator just in case. But other than that, is there any other comments for this particular ref type?
Yes. So I understand there's some technical questions. I'm not really the expert, but I'm kind of wondering about like what the overloads look like, because I know you have a GL demo that I couldn't find, to be honest. And the proposal doesn't go into too much depth. The way I understand that a span would implicitly convert to ref or also to pointer, I think. Is that right?
To ref
Pointer
only.
does not. Yeah, pointer does not have any managed implicits.
Okay, so only so span does implicitly convert to ref, but not pointer.
Yeah,
Yes.
it only implicitly converts to ref, because that way we can keep tracking. Yeah.
Okay. Yeah, just making sure. So my question kind of is for functions that take the count and the ref, what happens? What does the overload look like? Because the ref, fundamentally, I've already given the function the count using the ref, and then I have to repeat it, or do we still generate multiple overloads? I'm not really sure what the actual overload looks like.
Yeah, so as this proposal stands, you will have to repeat it. What this proposal doesn't cover today, and this will probably be a subsequent proposal or a future revision of this proposal, is what we call in build tools is complex overloads, but what's probably a better name is signature transforming overloads, or whatever name you want to put on it, when we're yanking out parameters or putting new parameters in, or fundamentally changing the function beyond what was specified in the original API signature. Things like changing GL gen buffers to just GL gen buffer for just generating a single buffer and passing the return value. That also falls into this category and hasn't been addressed in this proposal. So I do want to do cases where we can collapse a for example, a count and a reft into just a span and provide that as an overload, because, well, if we've got 16 pointer parameters, well, unless we've also got 16 counts, we can't collapse it down like that, and even then we can probably just provide one overload with all of the collapsing done, and it be sensible. So I'm not saying that this proposal is a exhaustive final list of all of the overloads that we will ever provide, but it's a start, and I do want to address that use case in the future.
So, I'm kind of wondering what you mentioned that you want to have overloads that do transform the signature.
Yes,
I
those would be
can't
proper
really-
overloads.
Yeah, I can't really totally imagine how that'll work with this type, and also avoiding the problem of generating a bunch of overloads, because that's kind of where the problem stems from, in my opinion. That you like have span and array and string, which have that, you give one piece of information and we give two to native, and you always kind of have to special case it with like separate functions because it has to be known at compile time.
Yes.
Yeah. So you have to generate a bunch of overloads there pretty much regardless of what you do.
I think
I feel like this kind of only avoids the problem for like a very small number of functions. Obviously, there's some functions that really benefit from being able to pass in a ref or pass in like a single element like span, or I don't know. But for most, I think most of our overloads really are related to arrays or to like multi-dimensional pointers, like where the number of overloads is a problem. That's probably related to like one of those, like either collections or like multi-dimensional, and both really aren't like addressed as far as I understand. So I don't really get like the API merit of this, to be honest.
What I can
okay.
kind of give here as the base example that we've used, the Direct2D problem, was actually strictly this problem. It was either you could pass in a ref or you could pass in a pointer. You do that for 16 different parameters. That's a large overload, and I would see that frequently in DirectX.
So, yeah, I think Kai has a valid point, but probably an exaggerated one. Primarily because if we are, you're absolutely right. A good user experience would be collapsing that count parameter down to just be a span, and calling it a day. I think it's opposite to how you've presented it, Kai, because I think fundamentally, again, build tools expose this concept as simple versus complex overloads, and realistically, we use the simple ones more than we did the complex ones, because the complex ones require strict metadata around like, well, is this a count parameter? Can we transform the function in this way? And you're absolutely right. For those particular cases where we want to collapse parameters down, those will have to be overloads, but I don't think it will be a bunch of overloads as you describe it. Because, for example, if you're using an overload that collapses one span parameter down, I think it is reasonable to assume that you will want to do that with all the other parameters that we can collapse down.
Also, how
whereas
common is it to have many things many parameter pairs that can collapse?
It won't be that common, I don't think.
There's a lot of this is kind of the same issue and scenario as how do you know that a character pointer in C, is it whether it's a string or byte buffer, or if it's meant to be a single character or anything else. You can't, given an arbitrary API, know if a corresponding integer parameter is a count length size whether that is elements, bytes, or something else for the corresponding T that it may or may not be tied to, whether it's tied to multiple pointers and indicating that that they all need to be the same length, whether it comes before, after, or some arbitrary other position, whether it's a member of a shared struct. All of these are scenarios that happen across the various APIs, and so you can't really know implicitly without something like SAL annotations telling you here's how this parameter ties to this other parameter.
I mean, for arbitrary APIs, you can't, and I kind of throw DirectX into that pile because they don't have any kind of fancy features. But
That we
for
parsed today.
most of the right, I don't know. I don't really have any clue about DirectX. I don't want to like. Maybe I'm wrong. I'm sorry. But like for most of the other APIs, so for OpenGL, for Vulkan, for OpenXR or VR, for all of the Cronus specs, and I think those are like the most used ones. Might be wrong, but I feel like at least we have all the information, and it's not really that we can't like make accurate predictions about what the C#, like the ideal C# typing would look like. I think for most of the Chrono specs, even though they sometimes are a bit wonky, for like most of the Chrono specs, we can make a pretty accurate prediction about what the like ideal typing looks like. And then sometimes users want to like sort of circumvent that because they integrate with like a third party or because they just prefer unsafe or something like that. But I think it's like, to me, I think doing the high level, like the high level is more important than having a like somewhat unsafe abstraction, which I feel like being able to pass in a ref or a pointer is kind of the same to me because it's just a single line of code that I have to add to convert. While for I don't know, doing like counts everywhere, it's like I have to do the span and then I also have to pass the count again, and I feel like at that point might as well just go unsafe. So I don't think it's so accurate to say that we can't know or that we like would have trouble to make these. Also about the like simple versus advanced overloads. I'm not super sure about the build tools here. Correct me if I'm wrong. I think advanced overloads emit like done C#, and the simple ones are handled by SilkTouch. Is that right?
Sure, but that's an implementation detail.
Yeah, I know. I'm just like, because I know about the simple ones, because I like did so much with them. Like that's why I kind of like ask, because I'm not super sure always. I think that like there's a bunch of simple overloads that you don't handle right now, and where you still need to generate overloads, right? Because there's like delegates, and then there's I think initialization, there's pinning. I don't know how or if you handle bools. Like there's a bunch of like yeah. I think it's just pointers and refs, no, and then like some fancy things for span.
Yeah,
that we've used so far.
And I have no doubt that this is not exhaustive. So this is the start for the simple case, like for the 90% of signatures that our users will use, because the complex ones are quite limited in scope. In that, well, yeah, you're collapsing down a count and a pointer like to just be a span, sure, but there's not a lot of places where we do that today anyway. But again, I do want to add that. And in those cases, it will probably be more like Silk 1 in that we have styles of overloads, because we've already got 90% of the way in the safety aspects, so our users will be a lot less bothered about having to pick and choose one even friendlier overload, because they've already got a friendly base. And so it won't be a case of we generate every single permutation ever of complex overloads. It'll just be we generate each style of complex overload, because we already know that you've got a mostly safe fallback anyway that is mostly nice to use. The complex overloads are just additional niceties on top of the niceness we've already provided.
I mean, maybe it just kind of differs how I use Silk there. Because for me, I think the like 90+% of my like function uses are just all safe, and then I have like one, maybe sometimes once in a while, that like I for some reason it's more convenient to do the unsafe. I feel like there's not much use where there's most of the parameters are unsafe and then you want one safe one. So I kind of feel like this yeah. Like if most of it is unsafe, you might as well do all unsafe, right?
There's a significant amount of handling that users don't have to do with the safe overload. It's almost 90% of the unsafe code they don't have to deal with. And at that point, having to pass in an additional parameter, it isn't really that big of a deal, at least in my opinion. The having to use fixed, having to enable unsafe code for direct usage, and all these other things are much more impactful, at least in my experience, as to how friendly a user finds the API.
I mean, it's not
And
always just like I don't know. I feel like it's not just like the count. I think pointers are pretty much all users of Silk will understand pointers at some point at least. Many will even eventually say, "Oh, I kind of prefer to use pointers for this and that," which I understand. And then there's some that might use refs a lot, but I think most people might like accidentally create them using like ref or something. And then you have everyone uses like the array. There's a bunch of like cases where there's out for an array, things like that, and that will the way I see it at least, that'll be quite nasty to like deal with for the user. And then they have to learn a bunch of things which we try to otherwise avoid. Because like for me, like my like Vulkan code base, for example, is like mostly free from like complex like type handling, and it's just I pass in whatever I have right now, and it kind of just works. And so other people that like use the code base don't really even know how to do some things because they just didn't have to learn. So I think the like extra count and like having to like understand all of the like typing semantics is very bad.
I
And-
have a few comments here. I think the first one, and this is something that I said a while ago that I eventually managed to convince everyone to agree with, is that it is unreasonable to expect a user of a library like Silk to be able to use it without reading any documentation. On the second comment is that I agree that there is probably more things than just count parameters that we haven't discussed. But in any case, this proposal is not meant to be exhaustive. It's meant to be a start. And I think any discussions around the implications of such future overload should be discussed when we actually introduce such future overloads. And
I agree.
sorry, Tanner.
I'm just bringing it up because I think that the proposal is like fairly complex and like is quite fundamental. And even though I don't really even fully understand, and I'm certainly not an expert on like the technical aspect of this, it is quite complex. So I expect that there'll be a bunch of edge cases, which is fine. But then I kind of want to also discuss the merit of introducing all of this complexity. And as it's fundamental, I feel like not thinking about things we certainly want to introduce is kind of, I mean, at that point, sure, I guess we can introduce it and then see, but it's kind of hard to make a decision based on just like, oh, but in isolation it looks good.
I am going to. Oh, yeah, sorry, sorry, Tanner. I forgot about you.
Sorry, I was going to say what I'd honestly recommend here, especially since there's many cases where you can't implicitly convert it without doing something additional like parsing out Sal or reading the docs explicitly. What TerraFX has opted to do here is I expose the purely blittable bindings. That's what users get. There are some scenarios where something is common enough and central enough that I have then provided extension types, and I have allowed users to provide additional functionality or even overloads for convenience because it is that core. And so it almost seems like what you'd be better here is providing the two sets that you've got here. Provide the friendly names, provide the pure unsafe overload, provide the mostly safe overload. And then you have the ability for a user to come in and say, you know what, I really want to interact with Vulkan using the Vulkan HPP headers, which is a C++ wrapper over Vulkan. It's the official wrapper, and it gives it to you in a more object-oriented manner, and uses, in some cases, types from the standard template library and things like that. And it almost seems like if you provide this base, you give the users who want this slightly friendlier wrapper the ability to come in and say, well, let me write down an API proposal where we provide that safer wrapper, where we give you, rather than what I would call TerraFX interrupt Vulkan in TerraFX, you then have TerraFX.Vulkan, which is kind of similar to what I've got in ClangSharp, where you've got ClangSharp interop, and then you have ClangSharp itself. And interop is literally just raw bindings, whereas ClangSharp is mirroring the C++ Clang AST. And it gives you everything in an object-oriented, friendly manner. It abstracts away. You can pass in strings and spans and everything else. And that ends up being more work, but it ends up being significantly worth it, and you can focus on the individual areas where developers want it.
Yeah, I would agree there that this proposal doesn't magically make your code immediately friendly and immediately obvious what it's doing. And you will need to read documentation, but also it gets you enough of the way there. It hides the obvious things, the low hanging fruits almost, that you could write something on top of it. Like we've been discussing this with Asim for ages because their C interface is particularly horrible. But we're open to accept contributions to add back wrappers that look and feel more like the C++ API that everyone is familiar with and that everyone is documented. There's always room to build stuff on top of what we proposed here today. This is just the start. And as for the merit of this particular proposal, I will remove myself from this conversation because I'm extremely biased.
I think merit-wise, so the first question is does this provide utility to users? Is this doing something? Is this removing some boilerplate code? In most circumstances, and I think in a lot of circumstances, I'm mostly used the DirectX, so header, Silk so far, and that's where my experience comes from. There is a lot of times where DirectX is asking for pointers, not necessarily to lists, to single variables or locations where they're going to pass you back out a single variable. So a ref works fine for me in those cases. Whereas having to fix it all myself, it's just time. It's boilerplate code. It's something that if I didn't have to do, and I can know that there is a type that will handle most of my cases for me, yeah, maybe when I'm passing in a list, I have to pass in the list and the number of values in the list. For now, I think that's fine if we do end up adding overloads later that take care of that, but I rarely see functions that have many lists in it that I would want one to be a span, one not to be a span, one to be a span, one not to be a span, which would be getting us to that excessive overload issue. If there's a case for that, I'm willing to hear that out, but I think in most circumstances, this will help remove some boilerplate from users as they're writing their code.
Yeah, I do agree there. I think it is for like cases where, like in DirectX, as you say, where I don't have the like experience, so I don't really want to comment too much on what that looks like. There it certainly makes sense to have this proposal. I'm just kind of skeptical on principle because I think the system with just having overloads makes a lot of sense, makes is nice for IDEs and for a compiler, and works really well. And to me, there's a handful of edge cases that we have problems with, and proposal I think is good in those cases, but for most, like for like all the other functions, I can't really imagine how it's gonna work, and so yeah, to me that's more impactful what like the already working use cases look like versus having those, like, to me at least, handful of edge cases solved.
And this is just a question is because I know you're talking more about OpenGL Vulkan libraries and that sort of stuff. Do the overloads you're thinking of need to be mutually exclusive with this overload style? Because to say that, yeah, like I do agree, the great example of having a span when it's asking for a pointer to a list of elements and a count, and those we have all the annotations to know that, or the points where we know that it wants a string because we have the sal annotations, and I think those overloads are valid as a next step to take past this, but I don't think that that inherently makes this proposal not worthwhile, because that is assuming that we're handling it all managed and we're not handling data that's come to us from other unmanaged functions as character arrays, as unless we want to convert them out and then convert them back. So I think there are cases where still adding in the overloads is a great and valid solution, but I don't see why not necessarily having this as a base layer that those overloads work from wouldn't also still work.
Would agree, and I think this proposal works great for like the pointers and stuff like that. But the reason that I'm not that happy or that I can't imagine it is because if I think of it just additively, so we like have all the overloads and then we add this on top, which is obviously not the way it's necessarily supposed to work, but like that's the best way I can like estimate what like the end product might look like. Then I find it very hard to understand how or why there's, for example, a string conversion, because strings are just better handled by an overload like span, like we have like the existing works, because they natively convert to read-only span of char. And then it's just hard. If this is a base layer, then in my opinion, it's too extensive and reaches into areas that might be better handled by more complex solutions like string. I think string is I think very complicated to
String's
handle.
a good example to talk about because I think this is all well and good to talk about having these more complex overloads when we do have sal annotations and those things, but again, the goal is to have 3.0 as a generator we can hand out to other people and give to generate bindings to potentially proprietary libraries or libraries that do not provide extra metadata and annotations to work off of them. In those cases, having this a little bit more robust base layer that can take strings, it's not going to necessarily be as optimal as a strict string overloader where we know that that's what we want. But in cases where we aren't sure and maybe that is a valid overload, but we don't have enough information at generation time to know that.
Yeah, that makes sense, of course. But there, I just have absolutely no idea what that's going to look like at all. So that's very
Okay,
hard
well,
to consider, I think.
we'll figure it out when we actually have something to discuss then.
I mean, yes, the reason I bring it up is because once we say, oh, this proposal is good, we want it, I don't think we have much precedent for going back later and saying, oh, but actually this wasn't a good idea. So that's why I bring it up, because once we say string overloading and like converting strings to just a ref type, that's a good idea, then we probably won't go back on it at all.
Guys, this discussion that we're having here now is a precedent of us going back and saying, no, we don't want this. The proposal that was previously with this title was already approved by the working group, and we've gone back and vetoed it and changed it.
Yeah.
So we can go back. I'm happy to discuss more. I'm obviously wary of time, but I think if it turns out we go so far down this path that we encounter some massive thing that blocks us from adding more stuff, or that makes it a horrible user experience, we will have it would be irresponsible for us to not figure out a way of backtracking just because we've already approved it. I'm more than happy to, as things arise, come back to this forum and discuss whatever things are. We can't predict everything, and that has proven time and time again. With 1.0 and 2.0, we've tried to do something for the benefit of the user base, and there's been some implication that we haven't considered far, far, far in the future that wasn't on the table then, but is on the table when the issue started occurring, that we have started to have to design against. We can't predict every single use case in the future, but we can make a solution. We can propose something now that is generic enough that provides us a base to make more specialized things in the future. And should it not be appropriate for that, we can backtrack. But this isn't a series stream of once it's approved, that's it. It's immutable. There's always cases where we can go back, and I'm more than happy to have discussions as things arise.
Yeah, I mean, I'm happy to move on. I don't really want to hold everything up either. But yeah, I mean, the times we're backtracking, like right now or previously with 2.0, was a major version upgrade every time. So that would be a precedent if we were to move back on the proposal once approved within a version that we have never done that, I believe. So
I
don't know.
It might be also worthwhile to have this discussion maybe once we have our base set of bindings and seeing if there is merit to, if we think that these types don't necessarily have merit once we have full OpenGL and full Vulkan bindings. I don't know if we have plan on DirectX for base 3.0, but assuming that we have DirectX, that way we can look and see, do these types make sense and have a place, and then move backwards. I think I see merit for them, and obviously Perks does as well, but we're also the two people who have been working on this, so.
Yeah. Okay, so there is one, that was only half of the proposal. The next bit I'm hoping will be less complicated. This is the API interfaces / API objects, and basically how we're managing static versus non-static in 3.0. So a common complaint has been that we don't have static functions for things like OpenGL, and it is always something on principle that I have said, well, these are not static functions. They should not be static because they're inherently tied to state. But this doesn't change the fact that people have been corrupted by OpenTK, OpenGL.net, that these are static functions in those particular libraries. And also in C, there's no such thing as an instance function. This is where I've sort of backed down a bit and tried to come up with a way that not only allows those users to use inherently stateful bindings in a static way in some cases, but also to address some of the obvious inefficiencies that came from using a static library. A library where the functions aren't stateful, but we're requiring that the user uses them in a stateful way, i.e. through an API object, and try to make a more generalized solution. So this is what I've come up with. So we've got the API interface. We also have a static variant of that included as a sub-interface. And basically, it contains the API signatures, and it also proposes that we include the unsafe one already, and implement the safe one as a default interface method on top of that unsafe one, which we're not doing in today's prototype, but obviously if this proposal is approved, we have to do it, so we will be changing it. And then that comes into the classes that we generate later. So the idea is that we have a top level class representing the library. So this will be GL or VK. That has static functions on it, but it also has a create method, which is the new name for get API, because get API was a stupid name that people kept misinterpreting. That returns a it will return whatever is the default. So, for example, if the library that you're using is more optimized towards being used in a stateful way, then you pass in a iNative context. I noticed we haven't changed the proposal to reflect iNative context versus delegates, but the idea is that if it's more optimized that way, then you would use an API object. But if you've got something that's inherently static, then yeah, I mean, if you prefer having an object, we'll let you make an object. But fundamentally, you should be using the static function. And the idea is to be flexible to what the users want, but also provides in every case, the most optimized path, rather than forcing people to jump through our abstractions as we did in 2.0. Because again, it never made sense that D3D11 was a object and didn't have static functions, because those function pointers come straight from kernel 32, or in the case of DLL import, they come straight from the runtime. It never made sense to have to create an API object, and that was purely a byproduct of this abstraction that we had in 2.0. So yeah, this is implemented today, and it's again, we've got a working OpenGL triangle using this. I actually use the static functions just to demonstrate this, even though it's not the most optimized thing. Like, if you use a static function for interacting with OpenGL, when you're making that context current for that thread, it implicitly creates an instance and wraps that, and vice versa. If you're using a instance to access a static function, it wraps the static function in instance form. Discussions. Bearing in mind that we do want to get to maths, so that Maxine doesn't fall asleep.
So, if I understand correctly, the idea of this part of the proposal is basically to allow having for each API these static functions, but basically how they work is for each thread, they store the API object, so each time you call them, it just checks which API object is associated with the current thread, and it calls it on the object.
Or just OpenGL, that is, because OpenGL...
Okay.
Yeah, it's configurable in a generator, but generally the static function will do the most appropriate thing for that particular binding as configured when you're generating the bindings. Likewise, the API object will do the most appropriate thing for that particular binding. The idea is that it's impossible to have a one-size-fits-all solution. We discovered that in 2.0. So we expose multiple points of entry, and always provide a most flexible path, but also most sensible path for a particular binding.
Yeah. No, I mean, the reason why bindings are faster for Silk is we have that object, so we don't have to do all that work on the static functions. But if users prefer to use the library this way, then this looks good to me.
Is this really better than having some kind of than like exposing extension methods for VK instance, where you track the all of the potential VK get instance proc address results, and then you just have that be a you have the extension methods invoke into that, so that way they get the friendly access to the API. They don't have to manually track or count them themselves. But like treating them as static methods is fundamentally problematic because they aren't properly static. They're meant to be resolved dynamically, even if some implementation exposes them as DLL exports. It's more expensive to invoke those ones than to resolve the function pointer and call that, because it has to dispatch based on like which device are you using, and therefore is this going to the NVIDIA or Intel or AMD driver, and all of what layers do you have enabled. So do I need to dispatch to something else rather than the raw pointer you think you want to dispatch to?
Yes, so I think with this is designed exactly for that scenario, although it's not as friendly as you describe, and I do want to add more friendly wrappers like you described, like having an instance wrapper with instance functions on it. But that's out of scope for this particular proposal. But I know that DF Keenan has been prototyping similar wrappers for web GPU. And I'm hoping that we can take some learnings from that for applying that to Vulkan as well, for our first-party binding and having clean wrappers. But for the purposes of this particular proposal, it is designed exactly for that. So, for example, if you have a VK object and you're using an instance and a device on that, we will the intention is to automatically determine what device and instance that you're using and use the VK get proc address for that instance or that device, just like we do in 2.0. 2.0 is particularly finicky because I don't think users realize that we prefer for each instance device combination to have their own API objects, but we will automatically cache the correct function pointer. That is what this model is designed for. From a proposal perspective, this is allowed by this proposed API. The actual the implementation details of making an optimized path for doing so is to be discussed outside of this forum, but we can make ample optimizations using this model. And as I said, I do want to add more friendly wrappers like you describe as development progresses, because I agree, tracking instance functions on an instance makes a lot more sense.
Yeah, personally, just my thoughts on this. I'm very happy with this. I kind of went back on my thoughts on the static here. I think we talked about. I think we discussed in a previous group meeting also the idea of having like objects to track. The only thing that I don't think I see, or I don't think he explained functionality for like Vulkan. Do we still track individual like function like sets or something for like instance and devices, or what's the idea here now? Because the way I see the proposal, it would just work for the first combination and then it wouldn't anymore.
It's an interesting question, and this is again why I was very reluctant in answering Tanner's question to allude to how we would actually do that in our implementation. But I'd imagine it would be similar to how we do it in 2.0 in the sense that we do track the instance and device being used and load the appropriate functions. However, that is not applicable in every single case, and how we actually expose that to the user, if you want to then swap out what device you're using, is to be discussed. But for the purposes of this proposal, I think this is generic enough such that we can further propose things should the need arise, or expose functions for having more fine-grained control or whatever else. Fundamentally, this is just a way of exposing loaded function pointers to the user. It does not necessarily describe the mechanism by which it is loaded.
Yeah, I mean, I'm very happy to have this. Personally, I would also actually prefer having it crash with different devices, but yeah, we can defer that to another time if we want to. Even discuss it at all at some point. I don't know. But yeah, I'm very happy with this.
Excellent, cool. So for the outstanding things in this proposal, extension handling will be discussed in the future. Struct overloading, my nemesis, will be discussed in the future as well. What approval means for this particular proposal is to take the work that we've started in SilkX and bring that into the main repo. I have no doubt that there are more discussions to be had for this. And this is by no means the final form of this proposal, but if this proposal in this current form is approved, then it just allows us to bring what we've started in SilkX and continue it under the official Silk.net umbrella. Which is why I've left the to-dos here, and as Kai has alluded to, there are more discussions to be had around some of the more API-specific intricacies of loading such functions.
For Vulkan in particular, I think OpenGL technically follows a similar requirement, but OpenGL, for historical reasons, ends up not quite matching. But for Vulkan in particular, the way that they describe it is that all core, so symbols for all commands in the minimum version you target are guaranteed to be available as shared library exports. And it's only things beyond the min version that may be optional and that you have to use get instance proc address and get device proc address for. Will you then be doing caching for things beyond the min version? Or if the user's targeting a particular min version, will you just directly use the shared library export for efficiency reasons?
I think there's certainly some things to be discussed when we're actually implementing this, because you are right, there are certain guarantees that Vulkan does have with shared library exports. I'm personally always of the opinion that we should DLL import, or the equivalent of the VK get instance proc address function, and then you pass in null for the instance if we want to get functions without an instance, and just take it from there. I'm always skeptical, and it's probably reminiscent of my dealings with OpenGL. So this is by no means a correct opinion, but I'm skeptical of relying on such shared library exports being available, and I'd rather assume that VK instance proc address is available and that it will do the most appropriate thing, which is probably the same thing that just DLL importing it directly will be if we haven't got an instance. Relying on that doing the right thing.
Yeah, notably the reason why OpenGL ends up being so weird like that is because as far as I remember, OpenGL follows the same guidance as Vulkan, but the issue is that for historical reasons, most drivers only document themselves as shipping OpenGL 1.0, and so anything beyond 1.0 is functionally above the min spec version, and you have to query for it explicitly. Vulkan so far hasn't had that problem, and so if you ask for if you call create 421, then everything for 2-1 should be there, and otherwise 2-1 should fail.
Yeah. Yeah, I mean,
I guess it's 1-2 rather.
Yes, yeah, 1-2. Yeah, OpenGL has always been weird because it's technically never really defined the loading mechanism, but as we've seen on Windows, everything from OpenGL 1.1 is available. 1.2 has to go through. Bailey's going to hate me for saying this, but has to go through Wiggle to load the actual function pointers. But yeah, I think generally doing the most going the path that is most applicable for all the functions is probably the best way. And for the case at Vulkan, it will be using vgig instance proc address with a null as the instance pointer to load those initial functions, and then once we've got an instance, use the instance for subsequent calls to that. Cool. So I think if no one else has any other objections to this, we can let this through, provided we make the unsafe overloads available, and we also implement the special casing of read-only span of char, as we discussed earlier. Are there any objections to that? Notwithstanding any future discussions that we will inevitably have to have. Cool, I shall take that as a note. Maxine, we're discussing math. Wake up.
Maxine, get up!
So, I believe Maxine doesn't have a voice. So, Kieran, did you want to take the lead? Hang on, Maxine's
Sure.
typing. We should.
I can take the lead on at
Yeah,
least
cool.
what the general math proposal is, and kind of what it has included. This has been discussed kind of extensively with a lot of decisions around it. But the base idea is to update all of our math library to include generic math so that we can swap out, this is a float, this is, or instead we want a double or uint, all that sort of stuff, just to kind of expand our math library out that way. And also what has come along with this is kind of shedding some excess types that were more interrupt types and making this more just kind of a proper math centered library. The biggest part of this is redoing our types as both integer types and floating point types. Aside from Quaternion, which it was decided that Quaternion would just be a floating point type, it only supports floating type variables to be applied to it generically, just because a quaternion doesn't make a lot of sense as an integer. Otherwise, all types will have an I variant and an F variant. This really only has major effect on the vector types, but there is some fallout for certain functions not being available when we get to more of our geometry types. But the base idea is that we will have vector structs for vector 2 up to vector 4, both I and F variants. They will have a large number of specifications here of different functions, basically to allow them to function in kind of the standard operations that we expect. Most of this similar to how they function in 2.x. So we're mostly kind of trying to keep parity with that where it makes sense, especially with the F types, as that's going to be the closest to what we expect, whereas the I types drop a lot of functionality, like length and similar things that require square roots and other very specific functions that aren't available on integer types natively that we would have to do a conversion in back. We've just dropped that. But they do get some bitwise operators, our ands, our ors, and our exclusive or, and a bitwise negate operator. Unless we want to go through every single function that's listed here, does anyone have any issues with what has been proposed for the matrix types?
I think on my end for the matrix types, it makes sense.
Yeah, I'm fine. We've got the benefit of having discussed this both very recently and also very extensively.
Yes,
But
I read some of that.
well, okay, maybe Bailey doesn't have the benefit of that. But
I've kind of mentally disconnected from 3.x for the most part. I've been very busy.
So yeah, I think the general theme with these vector types is that for the f vectors we only accept floating points and therefore only provide the methods that make sense for floating points. And the same with the integer vectors, we provide only the functions that make sense for integers. Like if there's any point where we need to be doing any upcasting or downcasting just to make a calculation make sense, then we have omitted that. Is that a fair assessment?
Yes.
So I think given that, I mean, again, if anyone is interested in the specific APIs, they can, of course, look at the linked proposals. And if anyone has any comments that we haven't touched on in this call, then again, we're open to having more discussions after the fact. Approval does not necessarily mean that this is the absolute perfect solution and that we are going to stick with this no matter what. If you have any feedback on the APIs outlined here that are specific to one of the specific APIs here, then please do let us know in Discord or GitHub discussions or maybe even the YouTube comments, and we will address them.
There is one thing, just because I was looking back at the original proposal PR, because this was brought up by Katiara, and so I do want to bring it up, is this does have mention on vector types of doing all of, I think this was for the vectors or was for the matrices? Might have been for matrices, which if that's the case, then it might be a discussion when we get down to the matrices. There was a lot of discussions about things, and so I want to make sure that this is
okay. So at a surface level, does anyone have any issues with the vector types? Obviously, we've discussed intricacies over the past few weeks, and I'm sure we will continue to do so. But any comments before we move on to the matrices?
okay. So this was for vector types. So I do want to have this discussion. It was whether we should allow plus and minus component-wise operators with scalar types. Yeah.
For scalar types.
Yep, for scalar
Interesting.
types.
My
assumption was that if you were expecting to add a scalar, and there's no reason why we can't just add it across all the components.
Yeah,
I'd for subtraction and that.
I'd agree with that, and I think things like GLSL even expose this. Like if you multiply a vector by a scalar, it will repeat the operation for each of the contained elements. So I think that's a fair assessment.
So far in the BCL, we have only exposed that where there is a corresponding underlying instruction that allows that acceleration. So, for example, we allow multiplying by a scalar. We, however, don't allow addition by a scalar. both of them logically would work. It's just mostly been done to limit the amount of overloading that needs to be done. There is a potential perf advantage to that for non-acceleratable types, because you don't have to, first construct and copy a value to indifferent positions. So there's pros and cons on each.
Yeah, I mean, the performance first has always been system numerics' forte, primarily because it's effectively magic. We have obviously provided a lot more than what system.numerics provides, and generally we've always Silkmath has always been oriented as a gap filler library for the users that do not have their needs covered by system.numerics. So I think performance shouldn't be the be-all and end-all of determining whether we should have something in the library. Of course, we should be able to write something that's optimized. For example, it's not going to be an argument for adding a quantum wave function collapse algorithm in Silk.net Maths, because we probably can't make that efficient enough to be included on our types. But at the same time, something as primitive as repeating an operation 4 times using a scalar argument, it's I see that as benign.
We don't have any other comments detracting from that. I just thought I wanted to bring it up since there is not here to voice that. All right, then we can move on to the matrix types. For this, we are doing all matrices from 2x2 up to 4x4, and then also including a 5x4. The inclusion of a 5x4 being because this is used in Direct 2D, and it is also just a useful tool as a color affine matrix. So some of these types I don't know if we'll always have use for, but it does allow us to basically provide the use if a user finds a use for them, particularly like a 2x4 matrix. I can't see necessarily a use for them, but that was discussion that we had, since OpenGL does also expose all of these types. So I don't know if it necessarily uses all of them.
I had opinions here, in that something like a matrix 2x3 is likely going to be completely unused. And for the one case that it could be used, which is transposition of a 3x2, which is the row major version that the CPU can best deal with, you are likely better off exposing some specialized APIs of load and store transposed. That way you can push users towards the happy golden path of don't use a type that's going to be unnecessarily slow and cause problematic computation problems, while still giving them the ability to easily convert to and from the format that they need for things like GPU work.
Yeah. I mean, I agree in principle. I think we have found. I think we did look into this to see whether they would actually be used. OpenGL does expose some functions that we would, in theory, want to have overloads for these types for. So we've used that as a justification for keeping these not ideal types. I do agree. If we can find some way of encouraging our users to use actually sane code, then we should do so. I'm just not sure how we can do that without compromising the service provided by our by the mass library for the purposes of our bindings, without just making as just interchange types.
Is there any consideration for an analyzer that basically tells users don't use this outside of interchange then? So that they don't go down a path of they think that they misunderstand column versus row major because every single Stack Overflow article out there disagrees and gets it wrong. And then they think that using a 2x3 is better because they went and read some answer that said, oh, OpenGL is column major, but then they don't understand that, no, that's just on the GPU side, and that's just the default for the GPU side. And you can actually switch it, and the CPU side, like GLM, is row major. So you really don't want to use that one, you want to use the other one.
So I am absolutely in love with the idea of having analyzers for Silk 3, like the things we discussed earlier about the some libraries being more efficient if you use them in a static way, or some libraries being more correct if you use them in a instance way. I want to add analyzers for that, for instance, and there's a bunch of other analyzers that I want to add for the pointer types, and so many other things that I have kicking around my noggin that an analyzer would be perfect for. I see no reason why this also wouldn't be perfect for that. I really want to add an analyzer for stuff like that.
I think an analyzer would be a good way of pointing people towards doing the correct thing because it's extremely easy to use the wrong matrix type. So I think an analyzer is a good solution to make sure people don't use a suboptimal matrix on the CP side.
Yes, and as Maxine alluded to, we should document that.
Yep.
Yeah, I wholeheartedly agree that we should just pop in an analyzer and have it pop a warning for people. Is there, so with that, we'd be keeping all of these types and then just having an analyzer for users. That being said, going kind of forward, this is for the most part just keeping our matrix types as is. We are making sure, there's a discussion that's been had a few times, is for the most part you can only use compatible vectors when doing multiplication. The transform functions will allow for the homogeneous transformations. But in the standard just multiply case, it will multiply as you would expect mathematically.
How are you going to handle vector times matrix, given that something like a matrix 2x4 times a vector, whether that vector is on the left or right, and the size of the vector it produces is dependent on, or in the size of the matrix it produces is dependent on whether you interpret that as column or row major?
So I believe the assumptions we are making currently is that we are only going to do vector times matrix, not the other way around. And we are assuming row major for that. So that your vector going in has to match the row number.
I think by spec, so I think this is one of those cases where mathematically vector equals vector times matrix, which is what a lot of programming languages use as a shorthand for transform, is technically invalid mathematically, but it's common programmatically, and so that's kind of why I was asking, because it's one of those things where like it's one of those easy to hit corner cases that depending on your background you either understand or don't understand.
I know we went back and forth on this a lot, whether we wanted to or didn't want to include, and the actual transform, and I think this is technically all of these functions are listed under the vectors. not under the actual matrix type, these operations, but it is heavily related. Oh, and technically this does function the same as the transform, but because we are running under the assumption that these have to be matching types. The thing is it will function the same as a transform, but you aren't being allowed that homogeneous coverage. So you know, a matrix 4x4 can only be used with a vector 4 rather than allowing for the vector 3 multiplication. For that, you would have to explicitly use the transform. And at this point, we do not have any matrix multiplication aside from multiplying. Oh yeah, we do have multiply compatible matrices. This was one that was mentioned but hadn't really gotten much talk on it. Of, you know, you have a 4x4 matrix be multiplicable by another 4x4 matrix and give you the appropriate resultant matrix. And since we do have coverage from 2x2 to 4x4, those should multiply all across appropriately. The only one that probably wouldn't multiply correctly is the 5x4 matrix. You may not, probably don't have full coverage for that, so. Any concerns with matrix to matrix multiplication that I know?
I don't have any thoughts, but I'm not really the expert here. I mostly switch off when it comes to the mass types because it all gets pretty crazy pretty quickly, and all of the suggestions I've had my confidence slowly chipped away in those suggestions. So I shall leave. I leave the math stuff to the smart people.
I barely know what a matrix is, so.
What's a number?
4.
I'm not particularly worried about the matrix time matrix multiplications, and so long as we're straining our vector multiplication to only strictly appropriate types, so meaning it doesn't upcast or downcast in any way, shape, or form, it will match the transform overloads, so there's no unexpected behavior in this case, which is, I know, the discussion that's come up a lot of times of whether it would produce undefined behaviors.
Agree.
All right. Aside from that, each of these matrices include sensible operations. You know, invert functions are only available for square matrices. Technically, you can. This might get extended to the implied square matrices, like 3x2, 4x3, and 5x4, which are all implied squares. They should have a transpose function. The biggest difference is when we get to our 4x3 matrices of including both left-hand and right-hand variants of the create lookats, create orthographics, perspectives, all of that. I don't see any reason why this would be a problematic change, but it is a change from how it was done. Point X, I think it was just assumed based on, I don't know whether it was assumed left hand or assumed right hand previously.
We probably did the same as system.numerics, I'd imagine.
System numerics is right hand, which follows what XNA was using, which if I remember correctly, is the somewhat default that most OpenGL users use. DirectX is typically a left-handed default, but DirectX Math and GL Math, neither of them actually describe a default. They just have explicit left and right for both to avoid confusion. And beyond the standard left or right, there's also the confusion people get into and as to whether the upper left is 0, 0 or the bottom left is 0, 0, and whether uh, Z is up or Z is into the screen, or whether alternatively it's coming out of the screen with negative indices going in, because Z and Y basically get swapped all the time, and which you're using really depends on your game.
I don't
Yeah, so
think
I
that
think the explicit
necessarily
left hand
affects
and right
us.
hand helps.
Yeah.
And as for which ways which with regards to where 0 starts, where it ends, whatever, I think that is possibly out. Well, you just pass it a different parameter if you're working with I don't know, a model loader that assumes or some sort of external code that assumes one over the other, then you can still use the appropriate left hand and right hand functions. And then just, I don't know, negate a parameter or subtract a parameter. It's a lot easier to change which direction the axes are going than changing the actual left versus right hand calculations themselves.
Yeah, generally you want to just pick one and use it, and then you just change your world matrix by inverting, and that fixes everything. And Vulkan added some magic behavior in, I think it's VK create viewport, where you can specify, where as of like 1.1 and higher, you can specify different Y values and it will do the right thing to fix everything. Just by setting your viewport, so you don't have to do more matrix stuff.
Yeah.
Okay.
Cool. Well, I think
Do
we're all happy
we
with that.
have, yeah, any concerns with the matrix types as a whole?
You're missing notably some of the newer APIs that were added in 8.0 to the system numerics ones, like create look to in addition to create look at. And I think we exposed official create viewport.
Okay.
And then create billboard and create constrained billboard, I think, have left and right handed ones now too. I think they were approved but not implemented yet because they came in too late for 8.
I think that's worthwhile to include and to add on.
Ooh.
A lot of this was based on both 2.x and what Maxine has wrote, so I'm sure that that stuff kind of just got clipped under the wire for us, as well as we weren't necessarily keeping that close a watch on that. Moving forward, we have quaternions. For the most part, this works like how you would expect a quaternion to work. It's just going to be generic, allowing any floating point type. There any concerns? Anything that when people looked through this, things that they would like to see added or were concerned about having added here?
We don't have any Euler angle stuff, I've noticed.
Did I miss that? Yeah, we do. It's I went through the method that it's currently, which is create yaw from yaw pitch and roll.
Ah, thank you.
Yeah, because that matched what was the current naming scheme. That might have just been pulled straight from what Maxine's types had used.
Yeah, I'm probably just in my Unity mindset, as that's really the only time I used them.
Right.
That's fine. Yep, it looks like a Quaternion.
There's notably some no one likes Quaternions, and there's been newer innovations in the space where there's things that can be better than Quaternions, which might be useful to consider providing as alternatives. I don't think it needs to be part of this proposal here, but it's just more a note of there's been lots of stuff in this space. I think Freya Holmer has done a number of talks on it. And then beyond all of that, I would almost expect a general transform struct to exist as part of this baseline stuff so that people can correctly track the scaling, the position, and the rotation efficiently and combine them before you produce your final transform matrix. But those are kind of additional beyond what's been covered.
Yeah, I think that's beyond what we're proposing here, but I do think both of those things would be worthwhile, because having just something better than a Quaternion would always be nice. But as for the transform, it's not a hard thing to add. We're adding, 3 vectors, destruct, and then having some base, nice, easy functions with it. But I think that should be probably under a separate proposal. All right, if we have nothing else about Quaternions, the last part of this is the geometric types. I kind of very brusquely went over, added in the specification for these. First of all, the biggest change is we are dropping the box 2D and box 3D types and renaming cube to box, but we're also obscuring both rectangle and boxes implementation details so that they can be better implemented as mathematical constructs, not necessarily as they have been, which is more specific implementation details with specific interrupt types that we needed that could convert between each other, which is why we did have box 2D and rectangle and box 3D and cube. So we're kind of condensing that down. Aside from that, most of these are what you would expect of them. They have intersect functions with themselves, another of their instances, and a point. Then get distance to nearest point, edge functions, anything else that makes sense in that case. And then for our arrays and our planes, there's a get inflated function that takes a point and returns the scaled object that is closest to the original. It contains the given point. Scale and translation transformation functions, the box and the rectangle will have properties for the min, max, center, and size. That way we have both of our previous 2 types kind of boxed in there as types. You can still access it as you used to. Planes and arrays will have normalized functions. Planes also notably are getting a new from point normal function, create from point normal. Otherwise, these are also just functions that we have on our existing plane types, and the rest of this is expected to kind of function as they did previously, but generic versions of them.
Yeah, I'm happy with that. The only thing that we could possibly do, but this is more of a nitpick, is have a origin property on the types, even though it is going to be essentially the same as min. For people who are thinking in that origin and size mindset, they might not know that min is the origin.
I think that
But
that's
that's the only little
fair.
nitpick I could think of.
I would probably, instead of doing origin, have it just be center. That way you don't have the confusion there. You can just have.
Well, no, this is previously origin was a name given in, I believe, rectangle and cube for the min point.
Oh, I
We
see,
already
I
have
see.
center as another property.
I
So
see.
this is just to match. So if you're converting your code, you still have that origin property. Aside from it just being an odd duplication, just for a naming sake, I'm not necessarily against it.
Is that something where an analyzer code fixer can just identify users trying to access this, give them a quick fix that they can apply solution wide to replace it with min?
Is Roslyn smart enough these days to add custom code completions? I have a feeling it is.
I don't know.
Okay, well, something to investigate. But yeah, I guess this could be solved by an analyzer. I guess the only thing with an analyzer, oh, but can we add diagnostics to unresolved APIs? So if someone does .origin and there's an error that says, "Oh, well, this API doesn't exist," can we add our own code fix that says use min instead? There's lots to be discussed. I think we should maybe come back to it once we have more info.
Yeah,
But
I feel like this is one of those things that falls down to an implementation detail for how this property will get moved over, and whatever we find that works best for the user base is what we should end up falling on.
I'll just put that down as a future investigation then. Cool.
That's it for all of the generic math.
Oh, is that it? Is that
That's
3.0?
it.
Yeah. Cool. So what have we discussed here? I wrote some notes. So we're missing some APIs that like the create looks to, create viewport, create billboard, and constrain billboard left hand, right hand. And I think that's the only thing that needs to be changed about this proposal before it's approved. Please object if that is no longer the case. I hear no objections. Notwithstanding the missing APIs. Cool. Yeah, go 3.0. So I guess to discuss things going forward. So now that we've got, so obviously we need to change some of the. I've added this to the wrong PR. Whoopsie. I've just added those comments to the chain PR. So to going forward then, so at the moment all of the prototyping has been done in a repo in my personal area. Where the hell am I? Sorry, I'm just trying to multitask here, and as always it's going just as well as you would expect it to be. Okay, well I'll hunt down the comments later and put them in the right place, but going forwards, I suppose next up is to merge the current SilkX contents. Obviously, give them names that aren't SilkX. Now that we can put the official Silk.net branding on it, once we've adjusted the proposal, put the comments that we made on the SilkTouch proposal, and then go from there. I guess I'm very keen to get at least a super duper experimental feed up for 3.0 so people can start grabbing it and prototyping with it. And likewise, I want to start the preview cycle once we're in a similar position as we were in with 1.0 Preview 1. So that was, if I remember correctly, OpenGL, OpenAL, and no, it didn't have Vulkan, so it was literally just OpenGL and OpenAL and the windowing and input abstractions. That needn't preclude other previews. It's just, I think that's a nice initial set, because that way we'll have 2C APIs, because we'll have SDL3 hopefully, and we'll also have OpenAL, which are both using C headers, and then we'll have OpenGL that's using the Chronos. It's using ClangSharp plus Chronos extensions, so we'll have a good working set, and then obviously we'll do Vulkan after that, and all of the other ones like DirectX. Does everyone agree with that? Are we all happy to start merging things into the main repo?
Yep, I'm happy with that.
Cool, go 3.0 then.
Yeah.
Woo!
Let's go.
Oh, awesome! It's actually happening. It's yeah. I was looking through. So the original 3.0 tracking issue, because again, for some reason, we have consistently started planning the next major release before the current major release was even out. So we started planning 2.0 before 1.0 was even out, and we started planning 3.0 before 2.0 was even out. So it's technically been 3 years since we started planning 3.0. But it's been going for a while, and this is just a personal goal of mine, but I really love if we can get 3.0 out in some capacity, be that in the preview or RTM, by the 5-year anniversary of Silk, because that, I don't know, it's just like a little cherry on top.
Yeah, what day is that exactly?
That's some point in June 2024. It's like the 19th of June or something, 16th. I don't know. It's a teen.
Feels doable at the rate that we've been going, assuming we can keep momentum on this.
Yeah.
Yeah, I mean, I've got some stuff to do at the tail end of this year, but I should be all hands on deck.
Probably slow a little bit towards holidays. But...
Yeah, exactly. But I'm really keen to be all hands on deck after that. So 9th of June was the first commit to Silk.net 2019.
9th of June. Yeah, I think that's possible for a preview.
Excellent. Cool. Well, thank you all for coming in and taking time out your Sunday to discuss this. And thank you everyone for watching. As always, you can reach us in Discord, GitHub discussions, or the comment section. I do keep a loose eye on what's going on in the comments and the chat. Thank you everyone for coming. We will see you probably for the next Coffee and Code once we're a bit further along. Really happy we've got some stuff approved with caveats in every case, but nonetheless we can start developing 3.0 and start working towards the next latest and greatest build of Silk. Thank you. And with that, I shall say bye to everyone on the stream. The VOD will be available immediately afterwards, because YouTube is amazing like that.
Yeah.
All right. Cheerio. Right. Hang on, I haven't muted myself. Bye, everyone.